Hello, everyone. Let's get started with the next session. So please, everybody, have a seat. And let's welcome our speakers. I'm going to present them again. So my name is Andreas Kirsch. I'm your moderator for this Tech Talk, Lightning Talk, under the Technical Leaders' Perspectives on Generative AI topic. The speakers lined up have... It's quite loud here.
Yes, because upstairs.
Oh, yeah. Excuse me, the people upstairs, please stop talking. Thank you very much. The speakers lined up have significantly contributed to pushing the boundaries in this domain. Their collective expertise ranges from developing cutting-edge applications of large language models to pioneering generative deep learning methodologies. And let us extend a warm welcome to our speakers first. Yay. Our first speaker, Dr. Edward Kim, is a manager of technical staff at Cohere. At Cohere, Dr. Kim leads a cross-functional team dedicated to crafting interfaces for dialogue-centric applications leveraging large language models, so chat models. He holds an additional appointment as an adjunct research professor at the University of Toronto in the Department of Materials Science and Engineering, where his guidance is instrumental in exploring the confluence of materials informatics and large language models. Dr. Kim's illustrious academic journey culminated at MIT, earning a PhD in materials science and engineering with a strong focus on employing natural language processing and generative modeling for advancing materials discovery. His work has garnered attention from outlets like MIT News and The Verge, and before joining Cohere, Dr. Kim lent his expertise to several notable projects, including ML systems for accounting software Xero, AI applications for chemicals and materials at Citrin Informatics, and NLP for pharmaceutics at Pfizer. And then, following Dr. Kim, we have David Foster, the author of the best-selling O'Reilly textbook, Generative Deep Learning, Teaching Machines to Paint, Write, Compose, and Play, which was, I think, the first edition was published way before the latest wave. But there's a new edition out as well, I think. David is also founding partner at a London-based consultancy, Applied Data Science Partners, where he inspires and empowers organizations to harness the transformative power of data and AI, holding an MA in mathematics from Trinity College in Cambridge and an MSc in operational research from the University of Warwick. David is also a faculty member at the Machine Learning Institute. His research interests include enhancing the transparency and interpretability of AI algorithms, and he has published literature on explainable machine learning within healthcare. And then our final speaker for the session will be Dr. Rodrigo Mendoza Smith, the founder and CEO of Quine. And Quine aims at creating a monetization layer on top of GitHub, semantically matching developers to paid contribution opportunities in open source. Dr. Mendoza Smith's academic laurels include a PhD in mathematics from our esteemed University of Oxford, where he designed robust numerical algorithms for compressed sensing and topological data analysis. And post his Oxford journey, we saw him embracing the role of a data scientist at multiple investment funds in London, devising models for equity trading and algorithmic deal sourcing. And prior to Quine, he imparted knowledge as a visiting professor in applied mathematics at ITAM in Mexico City, and notably, Dr. Mendoza Smith co-founded the Oxford Artificial Intelligence Society in 2016 and continues to serve as a board member. And so together, all our three speakers represent profound knowledge and practical acumen in the field of generative AI, and well, I've talked for long enough already, so let's introduce them, and I'm going to hand over to Dr. Kim. Thank you very much.
I think it should be a Google Slides.
Come on. No. No.
Called like technology tree. Oh yeah, hey.
There you go. Got it there. We get there in the end, Sunday afternoon.
Yeah, all good. 100% been there before.
There you go. And you've got to click it there.
Oh, sweet. Okay. Yeah. Okay. Cool. All right. Thank you, everyone. I know we're running a little bit behind on time, so I will do a bit of a speed run on this where possible. I'll start by just talking about Cohere to give some background information. So Cohere is a Series C company. We're backed by investors including NVIDIA, Oracle, Salesforce. We're led by our CEO, Aidan Gomez, who was a co-author on Attention is All You Need, which you may know as the paper that introduced, there we go. Okay, good? Okay, cool. The paper that introduced the transformer architecture, which of course is the T in GPT. So about myself, I'm a manager of technical staff at Cohere, so I lead a mixture of machine learning engineers, software engineers working on conversational AI. I'm also a professor at University of Toronto in material science, and I live near Toronto. So, okay. LLMs are a foundational technology. I was going to say a lot more, but honestly, hearing all the discussion here, I don't think anyone disagrees with this at this point. It is a world-changing technology. But what does foundational really mean? That can mean a lot of things. We call them foundation models. Here's my argument. If you've ever played Civilization or StarCraft, if you're not into video games, that's okay. The idea is that foundational technologies are along this main branch of technology, and they unlock other paths in the tree. The best real-world example of this, I would say, is metallurgy. Right? There's like the Iron Age, Stone Age, Bronze Age, et cetera. The core main branch of technology is refining metals, but it leads to all kinds of other technologies. Right? Some people would say we're now in the Silicon Age, where purifying silicon wafers is the actual core technology, but of course it leads to computer chips and all other kinds of things. So what I want to convince you of in this talk is that LLMs are this kind of foundational technology. They unlock many other interesting branching paths, even ones that are different and new use cases than the ones that they're necessarily optimized for. So at Cohere, we build large language models for the enterprise. So we focus a lot on privacy, data security, deployments on private clouds, and that sort of thing. So what you're looking at here is a linear view of the technology stack, or again, you could think of this as sort of a main branch of a technology tree. So in this slide, you kind of read it from the bottom up. And the idea is you have base models, right? This is like sort of autocomplete, I would say. Then you have command or instruction models, which, it's like write me an email, gives you an email. Natural follow-on to that is dialogue models, so that's like ChatGPT. And I would say where we are right now with the frontier commercial language models is search and retrieval. Right? So Cohere has one called Coral. There's also like Bard or ChatGPT with browsing, Bing, and so on. When you talk to them and they have search and retrieval enabled, they can look up at the web, they can look up other data sources, and they can reply using them. And so, of course, this is something that Cohere has invested in quite a bit. And so our main branch here is this idea of grounded conversation with enterprise data sources. You can imagine that if you're doing employee onboarding, right? Like, what's the Wi-Fi password? How do I set up this equipment? It's one thing to look up a wiki, but it's much more productive to talk with a language model that can cite its sources. So I have a screen cap here. I think just continuing with the analogy stream here, I'm asking about some current events in a video game thing. But the language model actually replies, and there are these highlighted text spans that the model itself has generated, and it cites to real sources. In this case, from the web, but they can be configured to be, let's say, an enterprise wiki or a database. So why this is useful is it allows for auditability and transparency, right? So you talk to a language model, you're not sure if it's a hallucination. Well, you can actually check. You can check it against whatever source it's cited. Okay. So again, let's talk more about this foundational model, tech tree analogy. What I showed you was this main branch, but what I want to convince you of is that, well, even if we develop the main branch and we're focusing on this, it actually unlocks all kinds of other use cases. So how do we make that material and tangible, right? Like how do you actually do that? There's a few different approaches. Right? There's fine-tuning, which is when you train the model on some more data. There's prompt engineering, so you can have very complex prompt templates, which are much faster than fine-tuning and lower resource, but it can be very brittle depending on how you set this up. And of course, the thing that everyone wants, what's much more natural and useful, is zero shot. That just means you ask the model to do a thing, maybe something it hasn't really done before, but if it's very generally capable, it can work sometimes and be very compelling. So in the last third of this talk, what I want to do is build up an example step by step, showcasing how the search and retrieval, or retrieval augmented generation, or RAG, that we've worked on quite a bit at Cohere and we're focusing on for enterprise use cases, like the ones I mentioned before, can also be used for quite different use cases. I'm going to show something that's kind of inspired by the gaming industry, but again, you could think of this for any kind of media creation. I realize this is like wall of text, so don't worry about reading the whole thing at the bottom. What I'm showing you is an API input at the top that's in the black box. And I want to clarify here, this is not cherry-picked, and this is not like this is like an actual API call I sent last week on our prod system. It's in public beta to the chat API that we have. So I just make up some characters. It's actually important that I just make up characters here. If I asked about real or canonical ones, let's say like Gandalf, like the model would have enough pre-training knowledge to have a good answer. So I make up some characters. And I've bolded some parts. We can see the model gives some hedged hallucination, right? This is because models are trained to like kind of not be biased. They're trying to be useful. So you ask about something that it doesn't know about, it'll just hallucinate an answer. So this is like conversational models, right? This is the dialogue in the tech stack or the tech tree branch. But if you move up the tech stack, you can keep getting more capabilities. So we have something called preamble overrides where you can tell the model like you are a something. So in this case, you're some kind of ancient wizard, and you can see that tailors the tone. Again, the reason we developed this and the reason our customers use it is for things like luxury retail versus sports retail, and you're doing customer support chatbots, right? Like they should actually talk differently, and so you can steer the model this way. But what we see is that you can actually steer the model a lot of other interesting ways as well, even for other industries. Now, finally, I want to get to RAG. So this is retrieval augmented generation, where the model can search something, look it up, inject it back into its own prompt, and then learn to reference it and ground generation on new facts. Again, the reason we developed this are things like, let's say, employee onboarding, for example. But what you can see here is that in this API call, this yellow highlighted text, you can actually inject arbitrary text. So again, for these fictional characters I made up, I just made up some more facts. I picked weird facts on purpose so you can tell really quickly when it's actually citing versus hallucinating. So there's a castle built out of diamonds. There's a dragon that breathes laser beams. The point is he's identifiable. And when you look at the response now, the bolded parts and the footnotes, like those are actually generated by the model. Like before, the bolding was just to like draw your attention. Here, those spans of text and where they're attributed to and which documents, like the model is actually trained to be able to do that. And so what we see is that a foundational capability that has just come out, the gap between that and other branches in the tech tree is like almost instantaneous, which is not something you would have seen in a technology like metallurgy, for example. Okay, so summing that all up, it's quite interesting now that we're at this stage where LLMs are getting new capabilities like every few months, which is kind of crazy. And what's amazing is that advancing this linear path of the tech stack, right? Like each of these different LLM companies have slightly different focuses. As I mentioned, Cohere's is enterprise. It doesn't actually make the utility of the model as quite that linear, right? It's actually a little more branched, a little more general. And so the example I focused on here is showing that retrieval augmented generation, which is meant for sort of like grounding and very matter-of-fact use cases, can actually be used to make the model more creative as well. So if you want to try it yourself, you can go to either of these links, and that will bring you to a UI that's grounded to like web search, but you can ground it to a custom domain, for example, like a company's website. And the API calls I showed you are again, like they're actually out in public beta, so you can try it as well and try steerable language models with grounding. Okay, cool. That's it. Thanks, everyone.
Should I just be, I just want to ask about the competitive space essentially. How do you see, because usually like it's always just like OpenAI and Anthropic in the news. Can you tell us a bit more about like also Cohere and more it's like it's B2B and like the successes in that area? Because I feel like usually OpenAI and Anthropic get too much air in all these news cycles.
Yeah. Yeah, no, that's a great question. So I would say sort of a major differentiator in positioning is that we are enterprise focused. And I don't want to say that just as like a buzzword, but what I mean is that statement is actually quite all-encompassing in what the company does and what Cohere does. Right? It's not like when you're in a big, high-stakes B2B contract, you can't say like, okay, here's your model, bye. Right? It's like enterprise-focused, and delivering on that means the model has to be good, the platform has to be good, the infra has to be good, the customer support has to be at a very different tier and style than in B2C. And so all of that is sort of encompassed into how Cohere not only does like technical development, but also our operations and the way we interact with customers. So that kind of positioning is very much where we are intentionally trying to sit and sitting. And when we hear feedback from like kind of prospective customers we talk to, we hear that same feedback that we're, oh yeah, much more of that kind of enterprise B2B focus in our interactions as well.
Was it? Yeah. Is your question? We can do both. Yeah.
I was curious about these, documents and the preamble for the prompt. How much further traction you think there is in model training versus just delivering that in the original prompt? Because obviously you can set up, here's a document to reference, here's a preamble of who you are, with these language models. And I've been seeing OpenAI and others obviously release features like this and yourselves. How much further do you think there is to go there for that kind of specific API calls with how the models are trained?
Got it. This is a very interesting topic. I can give you the hand-wavy technical answer, actually not for time constraints, because I don't think there's solid theoretical founding on this. So the heuristic answer is that with steerability tricks, I would say, like the preamble or like injecting documents, or even like few shot examples as chat turns is another way to do it. You can sort of, let's say, unlock capabilities that have been seen in pre-training and previous training steps. So it's like you're sort of narrowing down the field of what the model does, or biasing it in some way. I don't mean bias here in like the societal sense, but I mean bias in terms of the kinds of outputs, the tone, the topic. What you can't do is unlock new capabilities you never had in the first place, right? Like if you say like, you're a super intelligent AGI and can do anything, like that will not really have a boost on the model, other than like few % chain of thought type of stuff, but it can't fundamentally do a new thing that it couldn't before. So that's sort of what I think of it as. It's more like a funnel or narrowing effect rather than granting new things, except in some narrow cases where there's like clever chain of thought style tricks.
I've heard a couple of people say that prompt engineering is going to go away. Do you think that will happen in this generation of the stacks evolving?
I don't know if I'd say it will go 100% away, because in certain critical applications where, let's say you're plugging this into a business system where you're replacing an old model with a new one, and you have a very precise task you need to do and stay good at, I think prompt engineering is fine and makes sense because it locks in that extra bit of performance and stability. It would surprise me if that went away. But I do think it's going to be less brittle as models become robust, and also that prompt engineering will converge between the frontier models a little bit. Actually, chain of thought is a good example. Like a lot of models from, let's say, 6 months ago or something, or even the same frontier model 6 months ago, it's like you had to always invoke chain of thought as a user and know when to use it. Models are now better at knowing when to self-invoke it, even if you didn't ask it to. And that comes from learning from what users have done and what they've expected. And because lots of users will use multiple different frontier models, it's like they're all kind of learning from that same user expectation. So I think there's there'll always be a place for it for very specific applications, but I think it will become less of like a friction point and more of like a, like an optimization.
Hi everyone. While the slides are being sorted out, let me just start. I can introduce myself. So my name, first of all, can everyone hear me at the back? Just want to make sure. Yeah, great. My name is David Foster. I'm the author of a book called Generative Deep Learning that was published about 5 years ago now. I think at the time it was the first generative AI textbook on the market. The second edition has recently been launched as well and rewritten, obviously with a ton of new technology and a ton of new content, so do check that out. I'm also the co-founder of a company called Applied Data Science Partners. We're an AI consultancy based in London. So if you're looking to leverage some of these technologies we're talking about, then do come and find me. So what is this talk about? Well, here we are today, and this talk effectively is about whether this line exists. If we carry on doing what we're doing, do we reach artificial general intelligence? The definition up here from OpenAI is fairly broad. And I won't go into the detail of the different definitions because we could have a separate talk on that topic alone. But what I want to share with you today is my thoughts around how we might get there. And to talk at a fairly high level about these 4 epics, as I described them: ability, agency, augmentation, and abstraction. So we'll have a look at an example of each one, because I think we can break down the task of building AGI into these 4 streams. And I want to share with you pieces of work that have been run recently academically that advance these capabilities. So by ability, what I mean is that generative AI has the ability to reduce the cost of human-like thought to near zero. It's a great way to think about the technology if you're looking for a single definition. And more specifically, LLMs, large language models, are highly capable zero-shot learners. What does that mean? Well, if you take an example like this, This is a task that, if we look back 2-3 years, would have been impossible for any AI model to solve unless you trained it on like tons of similar examples. Why? Well, because it's using terminology it's never seen before, it's highly complex, there's weird rules about how the economy on this planet works. And yet now, with the technology that we have today, it's able to get back to us with a very reasonable question about what on earth we're talking about and ask for additional information without us ever having to show it how to solve these kinds of problems. This is what we mean by zero shot. It's had no previous examples of how to solve this, and yet here it is asking a very reasonable question back. So as soon as I provide the additional information to, this is of course ChatGPT, you can see it tells us that its battery's running low. By the way, I'll share these slides with anyone who wants them afterwards, so if you do want to. I might skip a few of them as we go through, because these slides aren't necessarily designed for a 15-minute talk. Oh, great. Yes, you can see here, obviously, we've all played around with the technology. We know that these are the kinds of problems that it can solve. And of course, it can give the output in the format that we want, which is here a JSON object. Okay. Another way of looking at ability is to simply look at benchmarks. We've already talked about today how open source is catching up with proprietary. You can see here the bottom models that are open source are actually in many cases very close to the likes of GPT 3.5. And the technology will continue to obviously improve on these benchmarks as time goes on. So that's ability, first stream. And I think when we talk about improving of AI systems, this is all we tend to focus on. We look at benchmarks a lot. But I want to talk about the other 3 streams now, which I feel are just as important. There was a paper released not too long ago where they put agents in a 2D grid world and asked them to talk to each other using large language models. And they gave them all personalities and different objectives. And they just wanted to see what would happen if you did that. So think of kind of like Pokemon on the old Game Boys, but where every single character was being controlled, both their actions and their words, by a large language model. And hey presto, they end up falling in love with each other. One of the outcomes from the paper was to show that actually one of the characters decided to host a Valentine's Day party, and the other characters started to fall in love with each other, but there was like weird sort of love triangles developed, and it all got a bit sort of crazy. But the key point I want to highlight here is that there's real commercial application for these ideas if you think about things like dating apps and whether there may be in future the potential for avatars within those apps to talk with another and find real sort of application of having an avatar-based system rather than having to actually have a human conduct every conversation. If we talk about how this is possible, well, it's all about augmenting and giving agency to the large language model. It's about saying to it, you exist in an environment, so therefore you will have memories of that environment, and being able to pull through those memories into your short-term memory in order to make instant decisions about a particular topic. So anyone who's familiar with reinforcement learning will see this outer loop here in gray is something that should be very familiar. It's the typical agent environment loop, but there is this inner loop as well that gives the agent the ability to have memory and to be able to store and retrieve those memories as it sees fit. And all of these decisions are being driven by large language models. Okay, so that's agency. Thirdly, augmentation, and this is often wrapped up with agency because it's also talking about having the ability to take actions in a world. But here, what's specific about this is that we give it tools. So not just having words and having dialogue with other agents, but it can actually use and develop its own tool-based system. This is another paper from very recently called Voyager, and it showed how you can put an agent using an LLM into a world, in this case Minecraft, in order to write its own code to take actions within the environment. So for example, this was one of the examples they gave in the paper, where the agent basically could take actions at random to begin with, and over time it realized that certain actions, when grouped together, were able to make it do things that were beneficial. And at the point at which it discovered this little block of code that was useful to it, it could write a description of what that code was doing in effectively like a comment or a doc string, and save that to its skill library, so that when it came across other challenges in future that could be solved using that skill. It didn't need to reinvent the skill itself. It could just go to its skill library and say, hey, I already know how to make a furnace or something like this. So they show over time, again, putting the agent in an environment with a large language model, but specifically here to write code to interact with that environment, that it could solve and conduct a load of different things that weren't explicitly trained into that agent to begin with. So you can see here, this is another example just showing how the task of crafting an iron pickaxe is something that using these large language models could be retrieved from the skill library using techniques like we've just heard about, like retrieval augmented generation. So lastly, abstraction. So this is one I think is probably the most interesting and the one that we have the least amount of progress against. And this is all about expanding to new modalities. We talk about large language models because the most powerful models on the market today are, broadly speaking, large language models. There are obviously text-to-image models as well. But in terms of applicability for businesses, most businesses will be looking to leverage an LLM to do their task. If you look at this, this challenge here, this is from the abstract reasoning challenge devised by Francois Chollet. As a human, we intuitively understand what comes next in this sequence. The left-hand diagram maps to the right-hand diagram because the blue line is extended and reflects off the red wall. We can describe that very accurately. But if you think about how a large language model would approach this, it doesn't really have much that it can do. You would first of all need to map the input space, which in this case is a grid of colors, into some sort of language-based tokenization system. And then it would need to reason within itself and then produce the grid back out the other side. So it's a bit like image to image that we're trying to solve here. And whilst there has been progress with inputting images to large language models such as GPT-4v, which was released recently, it still has really nothing to offer against this kind of problem. This kind of abstract reasoning problem where the world that it's operating in is very precisely defined, not necessarily by text, but also in this case by grids and colors. Here's another example. So again, you could imagine this kind of abstract world being tackled by an AI system today. It would very often make mistakes with this. And so the question we need to ask ourselves here is if we're really truly going to say AGI exists, and yet it still can't solve this problem, then we're obviously missing something. Because for us, this is easy. So why shouldn't it be easy for all of these impressive systems that we have today? Another way of thinking about this is how can we ground LLMs in some sort of reality that sits outside of text? A great deal of our interaction with the world isn't necessarily encoded within written language. And certainly these examples here are not something that's necessarily a language problem. And so mixing modalities, text, images, video, and everything else that we experience as humans is an ongoing problem for those developing AI systems. Okay, so these are the four streams, and I think you can break down the problem of AGI and a lot of the problems that are being tackled into one of these four. We're either trying to make them stronger, we're either trying to give them agency, we're giving them tools to do things, or we're trying to take what they can do outside the world of text into other modalities. So if we ask ourselves, how far along are we on each of these epics? Well, I think it's fair to say that ability has come first. That's the thing that we're driving the most. GPT-1, 2, 3, 4 are all major steps in ability. And we've already heard today about things like passing the bar, but also obviously ability in terms of their worldwide prevalence now. And it's not just ability for a small group of researchers, but ability for everybody to have access to. The second one I think we're furthest along at is augmentation. We do have examples in practice today in deployment of LLMs having access to tools and being able to carry out tasks. Agency, I think, is slightly more complex because we have to give it the ability to reason for itself and not go off on a tangent down some sort of recursive loop or stay really on task and not just have the ability to take a random trajectory that ends up not getting a particular task done. And then abstraction is the one where we have least to say at the moment, but I think is where a huge amount of the research effort is at the big tech firms. Just before I end, I also just want to talk about risks as well, and I think we can divide those into two kinds. We've heard about both kinds today, certainly. Pre-AGI risks, so this is the immediate practice of developing LLM solutions that are being put into production, and then post-AGI risks, which feel very different because here, these are often, in many cases, being talked about philosophically, but obviously, as we've heard today, there are some real immediate concerns that people are worried about if there is a hard takeoff. And so I just want to end really with one of my favorite quotes. If we look back at all of the kind of technological projects that have gone on over this century, they've all had risks, they've all had problems, they've all had challenges. If we look particularly at the moon, the Apollo missions, you know, JFK said we choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. So it's no different really now that we are experiencing these challenges, and we shouldn't shy away from them, but we need to embrace the fact that we do see AGI as something that has potential risks, and not necessarily just walk down the path without at least acknowledging them, and talk about the specifics as quickly as possible, and take the conversation into a space where we can talk about actual practical risks that we can look to mitigate, rather than talking too broadly for too long, because we don't want this to be too late before we reach the solutions. Thank you for your time, and I'm happy to take any questions. Thank you.
Hello, thanks a lot. Is it correct to think of this framework as a next generation of the Turing test to understand AGI? And the second part is, should we aim for AGI, or should we aim for cases that make our lives better, even if we don't reach AGI, in your opinion?
Yeah, I'll take the first part of that. So I think you said about the Turing test. Was that correct? Yeah. So the Turing test is a really interesting point here, because I think there have been proven now like many fallacies with the way in which that test has been set up, particularly around what happens if, as a human, you try to deceive somebody to not be human? What happens if the AI is still very capable, but we can tell that it's an AI? Does that not still deserve some recognition as being highly impressive? So, the idea that we just put an AI in a box and a human in a room, and we get someone to talk to them both, and if it passes the Turing test, that's AGI. I think that's now certainly not the way that people are talking about what AGI might look like. Could you repeat the second half, because I missed the second half? Yeah, that's a great question. I think in terms of ultimate purpose, this will be a continuum that we will walk along. I don't think, my personal opinion is that we will someday suddenly wake up to AGI. So it might be that we build more and more progressively impressive systems, and therefore that will have lots of practical application. But whether the goal is AGI, I think it will depend on who you talk to. Certainly, we heard earlier, the big tech firms are certainly betting big on this. Sam Altman, it's always been his dream that is the case. Demis Hassabis from DeepMind, that's his goal. But for consultancies and for big tech firms, then no, certainly not. It's their goal to improve processes, cut costs, improve efficiencies. So the question very much, I think, would depend on who you talk to.
Hi, thanks. Great talk. Just had a quick question about your sort of model of AGI, and I was just wondering, how does creativity and imagination fit into that? It seems that that's maybe something humans do, which is possibly beyond even abstraction and going into new...
Yeah, I think, well, it's interesting because I think creativity is something that many people would say we've already reached. We do have systems that are creative. What I think is interesting is will, and whether these systems are truly demonstrating their own independent will to do something. I would argue no, not yet, but I think others would say in future that's one of the dangers, is that they do. We're talking about the very sort of extreme take on AI, on AGI here, which is that they develop their own will to spin off and realize that humans are surplus to requirements here and therefore they don't need us. I don't see that as being a risk personally. I think there's a much greater risk that there's malicious use as a result of malicious humans using AI systems. But yeah, in terms of like creativity, again, I think we're probably at the stage already where we're seeing a kind of interpolative creativity. And what I mean by that is, would a large language model trained on data up until 1914 have discovered the theory of relativity? I would argue probably not, because there's such prior bias in the training data not to do so, that it would have an extremely hard time fighting that bias, no matter how much task implementation you put in, how much agency, how much augmentation. Because what Einstein was doing was deliberately trying to go against his training data and take the idea to the extreme, whereas there's such a pull for a large language model to stick to its training data, it's what it's been trained to do, that it's a different kind of creativity that it displays, which is a little bit like filling in the holes in a Swiss cheese block, I guess, rather than finding a new piece of cheese, if you take my metaphor.
Thank you very much.
That's you, yeah? Yeah, I have the one, thank you.
Let me just see. This one? Yeah, cool.
Yeah?
Cool. I think. Oh. I see. I think this is the other one. There's another one.
Just one you sent.
Is it the one you sent?
Yeah. Let me
Can we refresh it?
Okay, let's look again. Just one moment, guys.
I mean, it's not like I can use it on top of this one.
No,
Yeah,
we'll find it. Don't worry.
Is it this one?
That one?
Yeah, that one. Yeah. Cool. Thanks, man. Hello. Cool. Hello, I'm Rodrigo, founder and CEO of Quine. Quine is a platform. Yeah? Quine is a platform that helps developers build verifiable skill sets by contributing to open source and make money along the way. So I'm aware that this is the last talk of the session, and we're running a bit behind on time, so I'm going to just do an efficient presentation. I'm going to talk about generative AI and its impacts in the future of work. And at the end, I'm just going to do a shameless commercial about Quine. I hope you don't mind. So to start, I think it's, sorry. Oh, yeah. So for those of you who were yesterday at Nigel's talk from GraphCore, right? He was giving this prediction that in the future everyone will be a developer. We share the same prediction, and in fact we have some data that kind of shows that this will be indeed the case. What we're seeing here now is the number of developers that are on GitHub. This is the number of accounts that have some content on GitHub, and we can see that since 2010 it's just been following this exponential increase. Definitely, the market is trending as everyone will be a developer, but more importantly, it's trending to the fact that everyone might be an open source software developer. So in order to understand the future of work, we need to understand the present. And the present in this presentation will be this curve, right? This curve is the supply side of software developers around the world, or kind of like a representation of the supply side. And to understand the future of work, we need to understand how the agents in this supply side are transacting with each other, are learning new skills, are working, and more importantly, are creating content in open source. So that's going to be like the purpose of my talk. So yeah, like just to represent things a bit more abstractly, right? Like we will think of the developer labor markets as a supply-demand curve, and we need to agree on something here, and this is that for a developer, the alpha lies in this scarcity. So the more scarce the skill set of a developer is, the more they can make in the job market, and we have seen this repeatedly through the last decade. With blockchain, with functional programming, now with artificial intelligence. the scarcer you are in the market, the more you can profit by transacting with it and by trading your time and knowledge with it. So the current market is being affected by a few macroeconomic forces. And there are three main things that I want to touch upon here. There are three macro forces that are sort of introducing noise in this supply curve. The first one is education, and basically like how are developers now becoming developers, learning how to write code. The second one is certification, and this is how are developers proving that they actually have a skill set or that they are the best at doing something. And the third one, which we have heard a lot about today, is augmentation, right? Is it the case that 1 unit of time for a developer now is worth 10 units of time? Is it the case that LLMs will replace like a sector or a fragment of the work that developers produce? I think we're still seeing what comes out of it. But like the takeaway is that these three forces are basically affecting the supply side, right? So it's impeding us from knowing who knows what and knowing what is the efficient, say, like market price of skills. So how does the future of work look like? For us, it just looks like a very pristine supply side and very pristine market, a market with perfect information, a market where we have enough data to do an optimal allocation of talent, and more importantly, when we can quantify the experience of developers at a deep enough level that we can help them monetize at their efficient market pricing. So let me just guide you through these forces, starting with education. Why is education changing for software developers right now? Firstly, because now knowledge is free and is everywhere, right? Like maybe back in the 1990s, you had to be a graduate from some university to be able to write code or to work on software. Now knowledge is abundant and is free, which is very good for the market because we're getting a lot of new developers, right? Like basically now a lot of new people are entering the market as the previous graphs show. The problem here is that we're all learning the skills from the same sources, from the same YouTube channels, from like the same sort of pieces of content, which is creating a problem of difficulty in standing out. So in this decade, the problem that developers are facing is not that of acquiring knowledge, is a problem of being able to prove that they are different from other developers or that they are special, or that they have something in particular that they can sell and offer to the market. Which takes us to the problem of certification, right? How are these people proving their value right now? You might say, well, they have certainly a LinkedIn profile. They have a public profile that just shows where they have worked. It shows what can they do. The problem is that everyone has these profiles. These are often inflated. These are not verifiable, so it just creates noise. You might say, how about school? Like, you know, like they go to school, they get a diploma, which is true, but school does not often focuses on practical skills sometimes, and also it's getting more and more common that you can just buy a diploma by doing an online course, etc. That still it lacks that verifiability, right? Another way would be, how about portfolios? Many careers have portfolios. If you're a photographer, you have portfolios. If you're a developer, you might have a portfolio, and that's fine. And this can often work. The problem here is that portfolios are sometimes very unstructured pieces of data. It's just difficult to systematically analyze them, to systematically know what's special about a particular developer with a portfolio. And finally, there are like GitHub contributions, right? Like open source contributions. And we think this is essentially where credentialing lies and what can solve the problem of credentialing for software developers in the future. The problem right now is that very, very few developers have any meaningful open source contributions. So to understand what the challenge to analyze these open source contributions, we just need to to go through like the process of how they look like. So how do people contribute to open source? Well, I'm just gonna give like a top-down type of introduction here. The way they contribute to open source, well, we know that the world runs in computers, and these computers are basically run on code, and this code is managed through packages that we call repositories. Now, these repositories are maintained by a community of developers, right? Like they're basically often decentralized. And the way they orchestrate work is by broadcasting these tickets that we call issues. Issues basically describe what type of work needs to be incorporated in a repository, and just lets the developer community know, like what needs to happen. Then basically, like some developer will take on this issue, will solve it, and will go through what is called the pull request workflow. If you're a developer, you know what this looks like. If you don't, then what they basically do is they create a copy of the code, they work on the fix, they discuss it with the maintainer of the code base, and then they finally merge it. And then finally, right, like they deliver the actual final piece of code that ends up living in this repository. A lot happened here. And I don't know if you saw it, but there is a massive amount of data in this process that is just living there, right? It's up for grabs and is unaggregated and is unquantified. So let's rewind a little and let's review what data breadcrumbs we might be able to extract from this process. To start with, in the code, we can, by using the Git protocol, we can understand which developer wrote each line of code in a code base. So we can compute attribution of who can use specific packages, who can use specific libraries, who knows what language, etc. Then by looking at the pull requests that developers submit, we can essentially understand, and this is where generative AI comes from, we can understand the discussions that the developers maintain with the maintainers of the repository, and we can even understand the metadata of the issue, right? So we can start to get an understanding and paint a picture of what type of problems each developer is best able to solve. We can go one layer up and even look at the social graph of open source. We can basically understand which developer is co-contributing with another developer, and we can understand essentially like which type of repositories you often interact with. And we can even go like one layer above and understand the market of each specific code base, right? Like which companies, which developers, which packages, and which computers are running each specific piece of code, right? If you contribute to open source, how many users will be the end users of that particular code base? And that's basically what we're doing at Quine, right? And how can this help us, first of all, paint this very pristine supply-side curve and like give this information back to the developer? Well, first of all, we can use this data to quantify the reputation of a software developer. And developer software development is a work market, and there's a concept of reputation within each particular community. And what we're doing at Quine is basically processing these pieces of information, categorizing them using generative AI, and essentially like helping developers understand where they stand in a specific community, be it a language community or a topic community. We also help them prove with verifiable assets that are derived from open source contributions, what skill sets they possess and what they're very, very good at, right? So we read developers' code, we process it, again, like using Gen AI, machine learning, and are able to deliver to the developers these assets that they can embed, for example, in their GitHub profiles, so that they can show the world what they're actually good at. No fluff, no inflation, just honest, pure statistics. And by doing this, what we do is we basically help each developer build a verified specialism and prove that they are unique at something. let's remember that the alpha of a developer is in their scarcity. So you might think here, okay, but like, is there enough in open source? Is there enough stuff in open source for every developer to like be amazingly good at something? The answer is yes, and again, like shameless advertisement. With Quine, developers can understand which repositories can make the best use of their skill sets and basically like build an open source portfolio with us. And finally, yeah, like open source is very vast. This is a visual representation of the open source space that we derive by processing all code bases and categorizing them in specific topics. I mean, this basically is of course, it has been processed to like be visually very nice. But what I'm talking about here is there is really a lot in open source that people can specialize on. And so yeah, like essentially in open source, everyone can build specialism. And again, shameless advertising, with Quine, they can even make money while building this specialism. So one thing we're working on quite strongly is the problem of systematic talent allocation. This means for any particular issue, understanding with code and data who is the developer that is the best candidate to solve a particular issue just by using the information they have created in open source. And something that basically generative AI unlocks for us is this problem of onboarding. Sometimes the best developer to work on a code base has never had exposure in this code base. So basically, like the repository might be a completely new universe for the developer. And there's a lot of information that this developer needs to ingest to be able to contribute to this repository. So something that we're doing here is systematic onboarding to repositories and helping developers just navigate the kind of vast amount of information that each repository has, right? And yeah, like just to wrap up the talk, this is a figure that quantifies the public tech debt in open source and how that is growing every year, which basically shows not only that there's enough work for everyone to contribute open source, but also how critical it is that new developers that are entering the market build some open source experience by contributing to stuff that actually people are using and makes sense. So welcome to the future or present of developer work, and happy to take any questions.
Thank you very much for the talk, especially within the context of augmentation and what we've heard previously about AGI and agentic work. How many more years do we have as software engineers before agentic software engineering bots will take most of our work?
That's a great question. So I think, of course, there will be some tasks in software development that will be fully automated, but I guess like developers will always be necessary. The paradigm shift that they will have to go through is that they will have to be less builders and be more of architects, essentially, right? Like we still need developers to like make sense of code bases, make sense of contributions, make sense of code. So I think more than taking over is just a transition of developers transitioning from being builders to being architects and kind of, helping still architecting the future.
Thank you. Other questions? Okay. Oh yeah, is this for this talk? Okay, perfect.
Unless we don't have time. Hi, Rodrigo. That's super interesting. So I was wondering, do you have, what would be the incentive for a developer to contribute to a specialty that's, let's say, AI for good in a broad sense? So let's say we've got a we've got 17 SDGs, right? We're halfway to 2030, and we're in like 15% sustainable development goals. We're 15% in achieving them. Let's say we're super like techno-optimists and say that AI is going to accelerate all of the 17 SDGs. How could we leverage that community, Quine, and what would be the incentive for developers to contribute to those?
Extremely good question. So, in Quine, basically, we offer two incentives for any developer to contribute. The first one is reputation. And reputation, they get it no matter what, and regardless of what they contribute to. The second type of incentive, which where we're trying to innovate on, is not only giving them a reputational incentive, but also giving them a monetary incentive. So capturing the value that developers create in these open source communities and just sort of like transferring part of it to the developer. So I would say the upside for the developer is always reputation, as long as it's open source and it's actual code, and it includes some type of like technical content that they want to associate to their profile. That's what we're seeing is enough sort of incentive for developers to do it. I have to say that in the supply side core that I showed, we're already observing developers doing this just like on their own, right? Like developers contributing to open source, or like trying to say pull requests to Bitcoin Core or to PyTorch, just to get those kudos from the community that they have actually helped building this. So the reputational layer will always be there, and that's fixed. If, for example, these projects have some external funding that they want to maybe redistribute to the community, then that's like a secondary layer of incentive that can be unlocked, of course. Thank you.
Yeah, I actually wanted to ask this question to everyone on a panel. We know that AI will have an impact on sustainable development goals. What is your opinion? Will it accelerate it? Will it hinder it? Will it accelerate once and hinder the others? It's a loaded question, but maybe you've got an opinion on it.
I think with any project, it's important to understand what you're looking to do before you set out to start the project. So I think like with these sustainability goals, I think the way AI is going to have an impact is by trying to move a particular metric and be really specific about what you want that model to do, rather than just sort of think, well, we'll throw AI at a problem and maybe that will help. So I think, you know, generative AI has the ability to look across scientific research papers, for example, and find ways in which different applications of science could potentially benefit the sustainability goals. But, you know, that, as I've described it there, doesn't have an impact. It doesn't have a particular quantitative metric associated with what you're looking to do. So if I were you and you heard me say that, the first thing you should be asking is, what are we trying to actually achieve here? Are we trying to speed up scientific discovery? Are we trying to find new scientific discovery? If so, how do we measure that? And be really precise about what you want AI to do, because if we're simply doing something because it's the latest thing or just cool to say that we're doing it, then that's not the right approach. So I'd encourage anyone, you know, no matter what business you're in, always to have the outset of what do we want to improve here quantitatively, and let's get to a point where we can measure doing that as fast as possible.
Cool, yeah, I think all I'll add here is that I think it's a bit of a double-edged blade, honestly, depending on the user and the use case for these kinds of AI plus like very big picture strategic questions. What I mean here is that I've definitely seen users where AI is an accelerant. There's some kind of strategic question like sustainable development that they're trying to use AI to accelerate them. But there's also another category of user, and these can be the same person in different contexts, where it just actually gives you like intellectual laziness, where it's like, I'll ask the model this, and then it tells me a thing, and they just kind of do it without thinking. So I think that there's not, I can't really give a clear-cut answer here. I think that it's as useful as it could also be misleading, depending on honestly user discipline to some extent right now.
Thank you very much. As a matter of time, if you have more questions for our speakers, I'm sure they'll be around, also like in coming sessions, but also later. Let's thank our speakers very much, and obviously also the audience for very great questions. Thank you very much.